All right, guys, let's go ahead and get started. So we have a plus b equals 8, b plus c equals 14, and c plus a equals 12. We want to find the variables a, b, and c. So to get started, since each of these equations has two different variables, we're going to go ahead and need to use a mix of substitution and elimination in order to solve for these variables. So the first thing that I'm going to do is I'm going to take my bottom equation and I'm going to choose a variable that I want to solve for. I'm going to go ahead and solve for the variable c. So to do that, I need to subtract a from both sides, and that will give me c is equal to 12 minus a. Now that I have c solved for, I can go ahead and substitute in for the variable c. So I'm going to take what c is equal to, 12 minus a, and I'm going to plug that into my second equation for the variable c. So that will leave me with b plus c, well, c is now 12 minus a, so b plus 12 minus a equals 14. And this is just the equation with 12 minus a substituted in. Now, from here, I'm going to go ahead and simplify it. I'm going to take my negative a and I'm just going to put it in front of the positive b, giving me negative a plus b. I'm also going to subtract the 12 from both sides. So 14 minus 12 will leave me with positive 2. So I now have negative a plus b equals 2. So I now have two new variables, a and b. Well, another equation from our three originals that has those two same variables is the top equation, a plus b equals 8. So I'm just going to go ahead and move that down right below it. So I now have negative a plus b equals 2 and a plus b equals 8. Now looking at this, they have the same variables. So I can go ahead and eliminate some of the variables. Now with my a variable, I have opposite coefficients, meaning negative 1 and positive 1. So I can just eliminate right now. So by elimination, I just combine the values straight down. So negative a and positive a cancel each other out. 1b plus 1b is equal to 2b. And 2 plus 8 equals positive 10. So 2b equals 10. From here, I divide both sides by 2. 2b divided by 2 leaves me with just b. 10 divided by 2 is 5. Now that I have one of my variables, and again, I could have solved for c or a as well, just I would have gone through a different method of doing so. Now that I have one of my variables, I can just plug back in and solve for the other two. So if I plug b in for the top equation, I can solve for the variable a. If I plug b in for the second equation, I can solve for the variable c. So plugging b in for the top equation, a plus 5 equals 8, I subtract 5 from both sides, and I have a equals 3. Substituting b in for the second equation, we have b plus c equals 14. Substituting 5 in for b, we have 5 plus c equals 14. And then solving for c, we have c equals positive 9. So we now have values for a, b, and c, and this equation is now finished. So today we are going to be covering 3.8, HL postulate. We've been talking about HL in the previous videos where we've been leading up to this. And again, HL is just going to stand for hypotenuse leg. That's what the HL stands for. Our learning target today is I can prove two triangles are congruent by HL, hypotenuse leg. So let's go ahead and get started with some vocab from our previous lessons. Again, you don't need to write these down if you already have it in your notes, but this is the information that you need in order to be successful with HL. So the needed vocab is all about right triangles. Now again, the legs of a right triangle are the segments of the triangle that attach to the right angle. So I can see that A and B are our legs, and they will always be connected with the right angle. Meanwhile, our C value, our hypotenuse, that's the side of the triangle that's opposite the right angle. And it's always going to be the longest side of the triangle. We talked a little bit about this in our previous video, but we can't have a right angle and an obtuse angle in the same triangle. So this 90-degree angle is the largest angle that we can possibly have. And if that's the case, the side opposite that 90-degree angle must be the longest side, because if that's my biggest angle, the side opposite must be my longest side. Those are the angle-side relationships that we talked about yesterday. Again, we need to have right angles in right triangles. There must be at least one right angle. There must be only one right angle. And then lastly, we have Pythagorean's theorem. A squared plus b squared equals c squared. Pythagorean's theorem allows us to solve for a missing side length of a right triangle as long as I have two other side lengths. So this will be very useful for HL as well, and for just right triangles in general. All right, so this leads us to our postulate for HL. If any two right triangles have the hypotenuse and a leg congruent, then the triangles are congruent by HL. Now notice this is not side, 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 angle, side, or angle, side, angle. In fact, if I were to go through this, we would have angle, side, side. And as we can see, ASS is not one of our three postulates. In fact, it spells out a word that we can't use at school, so that's why we call it HL. Now, again, it must be a right triangle in order for us to use HL. If it's not a right triangle, it can't be used. So keep that in mind. And you may be wondering, does it need to be this leg? Absolutely not. It can be either leg. So if I have two right triangles, and they have the other legs congruent as well as the hypotenuse, these are also congruent triangles by HL. So keep that in mind as well. All right, so let's go ahead and move on. Why is HL enough to prove triangles are congruent? Why wasn't it included earlier? Well, it deals with Pythagorean's theorem, a squared plus b squared equals c squared. In fact, if we use Pythagorean's theorem, we would be able to solve for a missing side length. And since HL requires two side lengths, a hypotenuse and a leg, using Pythagorean's theorem, we'll be able to find the third side length. Well, if I have three side lengths that are congruent, those triangles would be congruent by side, side, side. So again, using Pythagorean's theorem allows us to find our third side length, which will allow us to show that the two triangles are congruent by side, side, side. Now also, if I'm able to find a second side length, then I may be able to say that the two triangles are congruent by side, angle, side. It just depends on the triangles that we're given. So if I have these two triangles, triangle ABC and triangle DEF, as we can see, I only have two side lengths on both of these triangles. Triangle ABC, we have the hypotenuse and a leg. In triangle DEF, we have two legs. So let's say I want to find this third leg here. The second leg, the third side of our triangle. Well, I can use Pythagorean's theorem. And don't forget, our hypotenuse will always be the variable c. So this would give me a squared plus b squared equals c squared. I plug in 3 for my leg, for b. I plug in 5 for my hypotenuse, c. So a squared plus 3 squared equals 5 squared. Simplifying that will give me a squared plus 9 equals 25. And then I want to get a by itself. So I subtract 9 from both sides. 25 minus 9 will give us 16. So a squared equals 16. Now the only way that I can get rid of a square is to take the square root. And what I do to one side, I must do to the other. So the square and the square root cancel. I'm left with a is equal to plus or minus 4. Now, we know that we can't have a negative value for a side length, so that's why it's only going to be positive. Now, if I look at these two triangles, I now have side, angle, side, and side, angle, side. But let's say I needed to find this third side over here, this hypotenuse. Well, again, I can use Pythagorean's theorem, except this time I'm going to leave the c squared by itself. It's going to be what we're solving for. So again, we have a squared plus b squared equals c squared. Our two legs are a and b, so 4 squared plus 3 squared equals c squared. 16 plus 9 equals c squared. 16 plus 9 will give us 25, so 25 equals c squared. And then again, to get rid of the square, we must take the square root of both sides. C is equal to the square root of 25, which is plus or minus 5. And again, no negative values would work, so our c value is 5. Now we can see that the two triangles are congruent by side, side, side. And on the other triangle, side, side, side. So triangle ABC is congruent to triangle DEF by side, side, side. And also, if we had the two legs and our right angle, we could say side, angle, side as well. Now, very important with HL. Just because you see a right angle, it doesn't mean that it's going to be HL. It means it opens up the door for HL. So if you see a right angle, it should send off an alarm saying, hey, I may be able to use HL here, But again, we can also use side, 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 or side, angle, side, depending on what we're given in the actual triangle. So just because you see a right angle doesn't automatically make it HL. It just opens up the possibility for it to be HL. All right, let's go ahead and continue on. So here is our first proof of the day. We're given that segment BC is perpendicular to segment AC, segment BD is perpendicular to segment AD, and segment AC is congruent to segment AD. We want to prove that ray AB bisects angle CAD. So to get started, we can write out our given information and draw what we have on our diagram. Now, from here, for statement 1 and 2, it says perpendicular. So we need to think about what perpendicular means. Perpendicular means that these two segments are intersecting at 90 degrees. So these two angles, angle ACB and angle ADB, those are right angles. Because if two segments are perpendicular, then they intersect at 90 degrees. You can also say that this is the definition of perpendicular. That's fine as well. And of course, for number 5, angle BDA is a right angle. That's the same exact thing as number 4. Again, I'm just taking that from statement number 2. Now at this point, looking at our triangle, we have right angles, so our HL alarm should be going off. It may be usable. And we also have a leg. So we need either this other side, CB and BD, to solve by side angle side, or I need segment AB. Well, segment AB is shared by both triangles. So therefore I can say that segment AB is congruent to itself. Before I do that, since these are both right angles, I can say that they are congruent to each other. So angle ACB is congruent to angle BDA because all right angles are congruent. Now from here, AB is shared by both triangles. It's a hypotenuse for both triangles. So I can say that AB is congruent to itself. And any time that something is congruent to itself, it's always by the reflexive property. Always. Now, looking at our triangles, we want to identify the hypotenuse. So if I draw an arrow through my right angle, it's pointing at the hypotenuse, meaning that AB is the hypotenuse. AD is a leg, and we have a right angle. So we can now say that these two triangles are congruent. Triangle ABC is congruent to triangle ABD by HL. And again, that's because we have the hypotenuse is AB and the leg is AD, and also our right angle. Now, from here, our goal is to prove that angle CAD is being bisected. So I can say that angle CAB is congruent to angle DAB because if two triangles are congruent, then the corresponding pieces of those triangles are also congruent. Now, if that's true, if these two angles are congruent, then that would mean that segment AB is splitting those angles perfectly in two, which would mean that ray AB bisects angle CAD. Because if a ray cuts an angle into two congruent pieces, then it bisects the angle. That is also the definition of angle bisector. So those are our answers. And with that, this proof is now finished. So we can go ahead and draw our box at the top to show just that. All right, next up. Given triangle KPR is congruent to triangle SAW, ray RM bisects angle KRP, and ray WT bisects angle SWA. Prove RM is congruent to WT. So first off, I write out all my given information. Now from here, I see bisect. RM bisects angle KRP. Well, if that's the case, angle KRP is being cut perfectly in half. So I can say angle KRM is congruent to angle MRP. And the reason I can say that is because if a ray bisects an angle, it splits the angle in two congruent pieces, or the definition of angle bisector. Now, from here, I can say the same exact thing for statement number 3, except this time I'm working on the other triangle. WT bisects angle SWA, so I can say angle SWT is congruent to angle TWA. And that's for the same exact reason as number 4, the definition of an angle bisector. At this point, we want to prove that these two segments, these two bisectors, are congruent to each other. So to do that, I need to prove that one of these triangles is congruent, so these two smaller triangles are congruent, or that these two other triangles on the right are congruent. So either the triangles on the left are congruent, or the triangles on the right are congruent. So I'm going to go ahead and focus on the triangles on the left. So if these two triangles, the big triangles, are congruent from our first statement, then I should be able to say that the full side length, WS, is congruent to the full side length, RK. And the reason that we can say that is because if two triangles are congruent, then the corresponding parts of those congruent triangles are also congruent. Now at this point, I can do the same thing with angle S and angle K. Those are part of the large triangles that are already congruent from our given information. So I can say angle S is congruent to angle K for the same exact reason, CPCTC. Now, the last thing we have to do before I can prove these two triangles are congruent is focus on these last two angles, angle SWT and angle KRM. And I can say that these two angles are congruent. The reason that I can say this is because I see the word bisect written twice. If I see bisect written twice, that opens up multiplication and division properties. So I'm going from the whole angle, angle W and angle R, that are congruent because the triangles are congruent, to these smaller angles. So would that be division or multiplication? Well, if I'm going from big to small, that's division. So it's the division property. From here, I can say that these two smaller triangles, triangle SWT or STW, is congruent to triangle KMR by angle, side, angle. Well, if those two triangles are congruent, these two smaller blue triangles are congruent, then that means that WT and RM should also be congruent. And that's because if two triangles are congruent, then the corresponding parts that lie on that triangle, meaning WT and RM, those are also congruent by CPCTC. With that, this proof is done. All right, with this proof, there is no chance that we're doing HL. If we look at this proof, there's no right angles. So again, if you don't see any right angles, that automatically means that HL is out. All right, our last proof of the day. Given that OF is an altitude and we have circle O, we want to prove that segment EF is congruent to segment FG. Of course, pause the video if you need to try this one out, and we can go through it together. So for this one, we first start by writing out our givens. So I have OF is an altitude, that's given, and circle O, that's also given. From here, in altitude, the definition of an altitude says that it goes from one vertex of a triangle and intersects the opposite side at 90 degrees. It's perpendicular to the opposite side. So therefore, I can say angle OFE and angle OFG are right angles. And that is by the definition of an altitude. An altitude intersects the opposite side at 90 degrees. We're also given that this is circle O. So think about what you know about circles. Well, in circles, radii are congruent. So a radii goes from the center of our circle to the edge. So I can say that segment OE and segment OG are congruent segments because all radii are congruent within a circle. Lastly, is there anything that's shared by these two triangles? Well, yes, OF. So I can say OF is congruent to itself, and anytime that something's congruent to itself, it's always by the reflexive property. Lastly, looking at these two triangles, we have a right angle, we have our hypotenuse because it's on the opposite side of our right angle, and we have a leg. So I can say that these two triangles are congruent by hypotenuse, leg. So triangle OFE is congruent to triangle OFG by HL, hypotenuse, leg. Well, if the two triangles are congruent, then we should be able to say that segment EF is congruent to segment FG, because those are parts, those are legs of this triangle. So I can say these two segments are congruent. EF is congruent to FG, Because if the triangles are congruent, then the corresponding parts of those congruent triangles are also congruent. All right, guys, that is it for today's lesson. Thank you guys so much for watching. If you have any questions, please let me know. Have a great rest of your day and take care. Thank you.